Imagine you've just built a smart greenhouse with multiple sensors and actuators, but when you try to upgrade the firmware or add a new sensor, nothing works, wires are mislabeled, and your code is a tangled mess. This lesson tackles exactly that problem. How to build ESP32 IoT projects that are reliable, maintainable, and scalable. You learn the principles of clean, modular coding, proper version control using Git, and designing hardware and software together so your system works smoothly from prototype to production. By applying these practices now, you'll reduce debugging headaches, make your projects reproducible, and ensure that your work can be confidently maintained or extended by you or a team. In IoT, clean code is not a luxury, it's a necessity. Naming functions descriptively, like read temperature sensor or update dashboard, immediately tells anyone reading your code what it does. Modular design separates sensors, actuators, and communication modules into independent files or components, making each piece testable and reusable. In ESP-IDF, the folder structure supports this. Main contains main logic, components holds reusable modules like Wi-Fi manager or MQTT client. Each module exposes a clear interface and hides internal details. Think of each module as a black box. You know what goes in, what comes out, and don't need to understand every internal line. Reflect. If you revisit this project months later, will the code make sense instantly? Git is your safety net and collaboration backbone. For ESP32 projects, track firmware, configurations, and documentation in a repository. Use branching strategies. Main for stable releases, develop for ongoing work, feature branches for new modules. Commit early and often with clear messages, like added soil moisture sensor read function, not vague notes like stuff changed. Ignore build artifacts with a.git ignore. Git allows you to roll back firmware if an update breaks devices, collaborate with teammates, and maintain a clean history of every change. Reflect. If a sensor integration accidentally fails across all nodes, could you restore a working version in minutes? Git ensures you can. IoT works best when hardware and software are designed together. Consider power consumption, communication protocols, sensor accuracy, and real-time requirements from the start. For example, an ESP32 node using Wi-Fi should implement deep sleep to preserve battery, while ensuring sensors wake properly to take readings. Map hardware to software. Don't poll sensors too frequently, handle errors gracefully, and balance task scheduling to avoid overloading the MCU. Document pin assignments, voltage levels, and dependencies. For example, a soil moisture sensor connects to GPIO32, a DC read converts voltage to moisture level, and data flows to the cloud dashboard. Reflect. How would a hardware change affect your software design, and vice versa? Let's apply modular design with a temperature sensor module. Sensor module.c handles ADC initialization and reading the temperature, while sensor module.h exposes clean interfaces. Main.c imports the module, initializes the sensor, and prints readings every 2 seconds. Separating sensor logic allows easy reuse across projects and isolates errors. Pair this with a Git workflow. Initialize repository, stage files, commit incrementally, and create feature branches for new functionality like MQTT integration. Document your pin mapping table for each peripheral. This approach ensures you can build, test, and expand your IoT system systematically without confusion or risk of breaking other modules. Many developers make the mistake of mixing unrelated code in one file, creating maintenance nightmares. Failing to handle hardware errors leads to unpredictable crashes. Ignoring Git wastes time during collaboration or recovery. Poor documentation of pins and configurations makes scaling hard. Expert practice. Modularize early, test each module independently, handle errors proactively, and maintain clear Git history. Think of each module as a small, independently testable system. Reflect. Which parts of your current project could fail silently, and how would you prevent cascading failures? Professional IoT engineering is about anticipating these challenges before they become critical. To reinforce these practices, refactor an ESP32 project into modular components. Sensors, actuators, and communication modules. Initialize a Git repository, commit incrementally, and practice branching. Document pin mappings and voltage requirements for at least 3 peripherals. Implement deep sleep in one module and verify proper wake-up behavior. Simulate a sensor failure and handle it without crashing the system. These exercises teach you modular coding, version control, hardware-software integration, and resilience, essential skills to produce maintainable, professional-grade IoT projects. By completing this lesson, you now understand core best practices for IoT development. Writing clean, modular ESP32 code, maintaining a structured Git workflow, and designing hardware and software together for reliability. Applying these practices ensures your projects are maintainable, scalable, and reproducible, giving you confidence in both personal and team-based IoT development.